Good afternoon. Today we're going to look at two really pretty easy sections. 2.4 deals with the circle and 2.5 deals with direct and inverse variation. We'll look at those three equations that I've got here. This first equation, x squared plus y squared is equal to r squared. That is the equation for a circle whose center is at the origin and it has a radius of r. That second equation, x minus h squared plus y minus k squared is r squared, is still the equation for a circle. This is called the standard form for the circle because when we put it in that form, we're going to be able to know what the center is and we're going to be able to know what the radius is. The third one is called the general form, and the general form says that we can move around where we're going to put the center, and we can certainly change what we're going to let the radius be. Excuse me. Now, one of the first concepts that we got to do is review something that we had early in the course of how do you complete the square for a trinomial. Let's make it easy on ourselves. 10x plus. Now, we did that one when we worked those. You look at the middle term and you take half of it. Well, half of this middle term happens to be 5 and you square it. Now you've just completed the square. And the reason that works is that this thing factors now into x plus 5 times x plus 5. And we can write it the short way as x plus 5 squared. All right, the next thing we need to look at is what happens if I have a negative for the middle term. You still do the same thing. Good afternoon, Kevin. Good to have you. You still look at the 8, you take half of the 8, and half of the 8 is going to be 4, and you put 4 squared. But this time the factors are x minus 4 and x minus 4, which means that it is x minus 4 squared. Okay, we're going to have to complete that square when we use this general form equation later on in this work. Let's do the easy ones first. And the easy ones is one like this. You got x squared plus y squared is equal to 36. Well, the center of this circle is going to be at 0, 0. So that's what we said. That's the equation for all of them. It has a center at the origin. And the radius of this circle is going to be 6. This number over here is always r squared. Are you with me, Kevin? No.
Yes, I am. Sorry about that.
To draw a circle, and he does ask you to plot these things in your course compass work. So you're going to locate your center, and my center is at 0, 0, and it has a radius of 6. So you're going to come out here to 6. Well, that point right here would be 6, 0. Now, my circles are not going to be good circles, but we can still get the idea. This point up here is going to be 0, 6, and this point back here is minus 6, 0. And then down here, the point is 0, minus 6. Okay, so every time I ask you to draw the graph of a circle, you're going to locate the center. You're going to use a radius. You're going to go right and left with that radius. You're going to go up and down with that radius. It's that simple. Let's don't make it complicated. Fair enough?
Yeah.
So if I tell you that we got a center at 2, 3, and I got a radius of 4. Okay. And then I want to draw the graph of it. Well, the first thing you do is you locate the point 2, 3. because that's my center. Now I want to have a radius of 4. So I'm going to go 4 units to the right. 4 units to the right is going to give me 6. And the y value is going to be 3. Now, as I said, it skews the fact that it's not a real circle, but we still can get the points right. I got to go 4 units to the left of 2. Well, the 4 units to the left of 2 is going to be minus 2 and 3. I've got to go 4 units down. Well, 4 units down from 3 is going to be at minus 1. And I got to go 4 units up from 3, and it's going to be at 7. As I said, I don't have it drawn to scale at all. This is my 2, 7 up here. This is my 2 minus 1 down here. One more time, Kevin, you simply locate the center, and whatever the radius is, you go to the right, in this case 4, to the left 4. You go up 4, and you go down 4. And that works every time. Fair enough?
So you, can I get that one more time? Locate the center, then go left to right and up and down?
Right, that radius, whatever that particular radius is. Now, we're going to do 3 or 4 more, so I think by the time we get through with them, it'll make a little bit of sense to you, okay?
Okay, yes.
All right, now, notice what happened in this one right here. I didn't give you the equation to it. The equation to it would be this: x minus 2 squared plus y minus 3 squared is equal to 4 squared. Now, I want you to notice that general form that I had up there said x minus h and y minus k. So when you got a plus 2 right here for your center, it's x minus 2. A good way to remember that, Kevin, is this: whatever x makes this 0, that's what you're going to use for your center. I had to use a positive 2 to make this 0, right?
Correct.
2 minus 2. Same thing right here. Whatever makes this 0 for your y, so it had to be 3 minus
positive 3.
Make a little bit of sense, correct?
Yes.
Okay. So if I give you one like this, then this is a new problem. Suppose that I tell you you got x plus 4 squared plus y minus 5 squared is equal to, oh, let's say 25. Okay, the first thing you're going to do is you're going to locate the center. Well, the center is going to be at minus 4 for x, because minus 4 plus 4 gives me 0. And the center is going to be plus 5 for y, because 5 minus 5 gives me 0, right?
Correct.
Now, your radius is going to be the square root of 25, and in this case, that comes out to be 5. Okay, so far so good? All right, so let's watch how simple it is to draw this mess. Minus 4, 5, let's put it here. Negative 4 and 5. Now, it has to have a radius of 5, is that right?
Correct.
So since it has to have a radius of 5, I'm going to go that 5 down right now, because I want to make a point and I want to say something there. Look, when I go 5 down from 5, I get y 0, is that right? So I'm on the x-axis with that point right there. Agreed? Now, I can draw my circle out here. Now, this point right over here is going to be the point 1, 5. You go 5 units to the right of minus 4. 5 units to the right of minus 4 is plus 1. Agreed?
Yeah.
Now, and you come back over here. You come back to this side right here. Your y value is going to be 5. And you're coming back 5 units to the left of minus 4. And that's going to put me at minus 9. It's not that bad. In fact, it's pretty easy to follow when you get right down to it. But let's try it one more time. X plus 4. So I had to use minus 4 to make that 0. Y minus 5. So I had to use plus 5 to make that 0. All right. Now, so what happens then if he throws one at you that's not in the correct form? All right, let's give it a try. Suppose that I got x squared plus y squared plus 6x. I got to be careful with these now. Minus 2y plus 9 is equal to 0. That's a bad choice. It's a bad choice because I can look ahead and see what the numbers are going to be, but darn it, I've already written it down, so I'm going to follow through with it. Okay, so what it says then, I have to complete the square twice. I have to complete the square with the x terms, and I have to complete the square with the y terms. I know how I can make this a much better problem, and we're going to make it a much better problem. Give me for changing it in midstream. So, okay. I'm going to wait and decide what number I'm going to put right here. First of all, we're going to complete the square with this right here. You take the 6, half of 6 is 3, and 3 squared is 9. So that means I got a 9 over here. Now, this is the hard part of this step. This is an equation. So when you add 9 here to complete the square, you have to go to the other side of the equation and also add to complete the square. Does that make a little bit of sense?
Yes, it does.
You have to keep it balanced, right? Now, the same thing with the y. You take half of the 2, and half of the 2 is 1, and 1 squared is 1. So that means that I added 1 right here. Fair enough?
Mm-hmm.
Now, so now I can make my problem up like I want it. This is going to be a minus 6. Now, notice what we did. We completed the square using just the x term, and we completed the square just using the y term. So this minus 6 has to move on over across that equal sign. So when I move it over, it becomes a plus 6. You can see that?
Yes.
All right. Now, so this thing is going to factor into x plus 3 squared. This is going to factor into y minus 1 squared. Now I got my numbers like I want. I got 10 and 6 is 16. So you can bet that I'll always give you one that'll be a perfect square over there, so it won't make it too complicated. Now, look at it. Where is my center going to be? What's the x value for the center going to have to be?
Okay.
What makes this 0?
Well, I mean, that's negative 3.
Negative 3. What makes this 0?
1.
Positive 1. And r is the square root of 16, which is going to be 4. Make a little bit of sense?
Actually, I got that one right.
And believe it or not, Kev, it's that simple. In other words, it's not complicated at all. If you can complete the square, which I think everybody kind of got that hang, you look at this and take half of it and square it and simply do your arithmetic. And
I really do want to understand it. It's very interesting to me. It's just always been perplexing.
It always seems like it's a little bit Greek. Is that what you're saying?
It always seems like I end up missing a step or a number, and I usually end up getting the answer in reverse. Like instead of 16, I would have gotten 32.
Yeah, or,
it's like I always do that.
All right, now let's look at this problem. At first glance, you say, well, this is not a circle because you beefed it up. You got a 2x squared, and you got an 8x and a 2y squared. What arithmetic move seems to be the reasonable thing to do right now? What if I just divided everything by 2?
Yeah, I mean, I'm looking.
Well, watch what happens if I divide this by 2. I get x squared. I got divide this by 2. I get 4x. Now, I'm on cheat because I don't want to recopy this mess. I divide this by 2 and I get y squared, right? Now, on the right-hand side, when you divide 0 by 2, you still got 0. So look at it. I only have one thing that I have to complete the square with. Well, same song and dance. Half of 4 happens to be 2, and 2 squared is what we're going to add, which means I got to add 4 to the right side. So this one is going to be factoring to x plus 2 squared plus y squared is equal to 4. Now, people have a tendency to have trouble with this one because it's a little bit special. You don't have any trouble with this. What x am I going to use to make this 0?
-2.
-2. Now, you say, well, wait a minute. What? I don't have a y term. Well, that means it is what?
0.
0. Does that make a little bit of sense?
Yes.
And then my radius is going to be the square root of 4, and the square root of 4 happens to be 2.
2.
Yeah, fair enough?
Very much so.
Okay, now, folks, that is the idea of drawing the circle. You get it in general form, which means in this case we had to divide everything by 2, and then you complete the square as often as necessary. And here we only had to complete the square with an x. Now, let me give you an instrument. And here's what the problem says. I'm going to tell you where the center is. The center is going to be at 2, 1, and it's going to be tangent to y-axis. Okay, that requires a little bit of geometry. The center is going to be at 2, 1. All right, 1, 2, and then I'm up here at 1. Now, I want this thing to be, this is the center at 2, 1, and I want it to be tangent to the y-axis. Tangent, Kevin, simply means it touches the y-axis. Okay? Okay. So that means it's going to touch the y-axis, and it's going to touch the y-axis at the point 0, 1. Now keep in mind that that center is over here at 2, 1. Well, here's the big deal. We know where the center is, so we can write this down. X minus 2 squared plus y minus 1 squared. Now, we got to figure out the radius from the picture. Look at it. Isn't this radius going to be 2? From here to the y is 2, right?
Correct.
So the radius is going to be 2 squared. That would be a hard problem if you didn't know what tangent means. But tangent means it simply bumps it at that 1 point. Fair enough? Okay. Oh, let's see. Here's another one that's a little bit more complicated. Let me give it to you. I want the center to be at 0, 0. And I want it to go through -2, -1. Now, first of all, we want the center to be at 0, 0. Well, that's pretty easy to do. Now, I want it to go through -2, -1. Now, here's the center, and this is a point that's on that circle. Now, excuse the fact that it looks like an ellipse instead of a circle, but the idea is still the same. I want this point -2, -1 to be on that circle. So this distance right here is going to be the radius. Does that make any sense?
Yes.
But it just touches the edge of the circle, right? Okay. So all we got to do then is find this distance. Well, believe it or not, we studied something here a while back called the distance formula. Fair enough?
Yes.
And the distance formula goes like this. It is the square root of x2 minus x1 squared plus y2 minus y1 squared. So I'm simply plugging into that formula, and that's going to be the square root of minus 2 minus 0 squared plus minus 1 minus 0 squared. So that's going to be the square root of 2 squared, which is 4, and 1 squared, which is 1, which is the square root of 5. Okay, so look at it. We know where the center is, so that means I'm going to have to say x squared plus y squared, because it was at 0. Now, and this number over here is always r squared, but we just found the radius to be the square root of 5. So this would be the square root of 5 squared, and that comes out to be the nice little number of 5. Now, he wouldn't ask you to draw this graph because square root of 5 is a decimal number. But the idea of putting the equation down is simple. So what made this complicated is that we had to use the distance formula to find the radius. So far, so good?
Yes.
All right, believe it or not, it's that simple. And I think that you're going to enjoy this next section because to me, it's pretty simple also. In the next section, is what we call direct variation. Okay. Let me write out the statement. Y varies directly as x. When I say direct variation, your formula is going to be some constant times x. Now listen to what I'm saying. When it is direct variation, it is the constant times the variable. Okay, so let's make me a problem out of it. Y varies directly with x, and y is 12 when x is 3. Find y when x is 6. Now, some of these things you can work out in your head, but I hope that most of y'all would just go ahead and always find this k. This is what they call the constant of proportionality. Now, you're going to find that k by using your first statement. I told you that y was 12 when x was 3. So you divide both sides by 3, and for this problem, my k is 4. Does that make sense?
Yes, it does.
All right. Now, you're going to rewrite your equation. Instead of saying k times x, you're going to say 4 times x because we just found for this problem, k is 4, right? Now, look what the question was. The question was, find y when x is 6. Well, that means in place of x, we're going to plug in what we just asked, and it's going to be 24. Does that make sense?
Yeah. Yeah.
Right,
Yes, it does actually. Now that yes.
Yeah, let me show you that might even make more sense to you.
Well, I mean, I see it now. 4 times 6.
Right, it's going to be 20. But watch this, which I think you probably know. Look what I did with the x. I doubled my x. Is that right?
Yes, you did.
So wouldn't that make sense? I have to double my y.
True.
Uh-huh.
Which also equals 24.
Amen, brother. And it works. Fair enough? It works.
Very, very fair.
Okay. Now, so suppose that I give you one y varies directly as x squared if y is 12 when x is 2. Find y when x is 6. Now, look what the problem was. So the problem says y varies directly as x squared. Well, this time you're going to write the formula down. Y is kx squared, not just k times x. Fair enough?
Yes.
Okay. Now, you use this first bit of information. Y was 12 when x was 2, and it so happens that 2 squared is 4, divide by 4. So for this problem, my k value is 3. All right?
Mm-hmm.
Now, so you're going to rewrite your formula. Your formula is going to be y is 3 times x squared. You find your k and you write your formula with it. Now, the problem says find y when x is 6. So you're going to plug a 6 in place of the x. So I got 6 squared. So this is going to give me 36 times 3. 36 times 3 is 108. So this time you can't predict too well. In other words, it didn't just triple because of the fact that we squared it. Is that right?
Mm-hmm.
Okay. I tell you what what it can do if you want to try to sneak through that back door. It tripled, but when you triple something and square it, it's 9 times as much. Is that right?
Yes.
Well, an interesting thing, 9 times 12 happens to be 108, which is the same thing I got here. Sneaky, but it gets you there. Fair enough?
Yeah.
All right. Now, that's direct variation. Inverse variation. Y varies inversely as x. Inverse variation, it is k divided by the variable. Now keep in mind, on that other page, direct variation is k times the variable. Inverse variation is k divided by the variable. Fair enough?
Mm-hmm.
All right, so let's make us a problem. If y is 6, when x is 2, find y when x is 4. Well, the first thing we got to do is find k. So 6 is equal to k divided by 2. Well, this time, doesn't that say k is 12?
Yes, it does.
All right. Now, so you rewrite your problem. So y is 12 divided by x. But the problem says find y when x is 4. So this is going to be 12 divided by 4, which is 3.
Mm-hmm.
It's that simple. That simple. Okay. Now let me make you a hard one. Okay. Here's what it says. Y varies directly with m. Well, here's what your equation is going to be. K times direct, it's x times z. Inversely with m, I divide by m. It can, in other words, they may call this joint variation. In other words, it varies with two things, with an x and a z. But when it's direct variation, it's times it, and when it's inverse variation, you're dividing by it. So this would be the formula that you'd have to use for that. Now let me see if I had anything earth-shaking that they did. Did you ever take chemistry, Kevin?
Yes.
All right. In chemistry, you had Charles and Boyle's laws. You had the gas laws.
Mm-hmm.
And one of them went like this. The volume of a gas varies inversely as the pressure. In other words, if in this room right here, we're talking about the volume of air in it. Well, if I increase the pressure and I just keep squeezing these air molecules together, then it has to have a smaller volume. And that's the reason we call it inverse variation. So PV is equal to PV. PV1, V1 is PV2, V2. In other words, when you put this thing in the other form, for instance, let's suppose that I had a pressure of 300 milliliters and I had a volume of 1200. Now, if I have a pressure of 600 milliliters, I'm going to have a new volume. Well, let's do the arithmetic and let's make it easier on ourselves. I can divide both sides of this by 600 and I get 2, and I get 600 is my new volume. Now notice what happened. I doubled my pressure, right?
Correct.
So I made my volume half as much. And that's the reason it's called inverse variation. Fair enough?
Yeah.
All right. Believe it or not, folks, we've done 2.4 and 2.5. They're not that bad. I suggest you go ahead and do them and get them out of the way. They're due Thursday night. Thursday, when I get here, all we're going to do is go over every problem that's going to be on test 1. Need to also remind you, and I've already sent out an email to that effect, that Monday night, you're going to have to take your third quiz, and the third quiz ends up with section 2.5. So we've covered everything you need for that quiz. And by all means, next Tuesday, set that day aside. Sometime during that day, you're going to have to use 90 minutes to take this first test. Any particular questions, Kevin, before we leave?
No. Can you hear me?
I can hear you.
Okay. We're the only 2 people in class.
Right now, yeah, but you can't talk too much because I'm going to download this thing. So whatever you say is going to be recorded.
Okay.
If you've got a particular question you need to ask me, just go ahead and call me on that cell phone number, and you've got it.
Yeah.
All right. Good luck.
The one that's in front of me right now, when we're changing the volume, this may sound silly, but all we're doing is calculating
the new volume.
The new volume, so the actual area of space containing the gas.
The gas. And keep in mind, it's not gasoline. It's not a liquid.
It's gas.
There's space between the molecules and they will condense.
Yeah, hydrogen.
They'll move closer together. All right. Okay. Have yourself a good day.
Thank you.